So if you guys would get out your either your notebooks or whatever you're taking notes with, however you're paying attention, let's go ahead and do this. We are talking about transformation of quadratics. Before we start, the reason I didn't put the objective up here is, I'll put it up tomorrow. I want you guys to relate this to what we've already done. For instance, this is what we did last chapter. And now that last chapter is finished, hopefully we can tie it together. And I will say, we only had 76 points in that first chapter. This next one, we're going to have about 70 or 80, and we're going to do it in 2 weeks, and it's all going to be pretty quick. We are wrapping up graphing quadratics, but building on what you already know. So this chapter, even though we've only got 3 sections that we even talk about, it's going to be worth the same as all 6 sections that we did last class or last chapter. So the points are going to get real. I also, before we officially start, I want to say this. Everybody in here that has not missed 2 or more assignments is passing. If you have missed 2 or more assignments, you are not passing. I just went through the grade book this morning and broke this down. So if you're doing your work, you're doing well. If you're not doing your work, your grade is not where it should be. If for whatever reason you guys have any questions or you need some help or you just need to let me know what's going on, please, please, please email me. I know I'm not great at responding to all the emails, especially in a timely manner, but you got to let me know. All right, with that said, let's talk about this and what this looks like. Now, this is nothing formal yet, but how has this been transformed? Or in other words, what is my vertex in this equation? Will somebody unmute yourself and let me know, how is this moving it? This x minus 1 is moving it how?
Right 1.
That just means it's moving right 1. That's exactly right. What's this plus 3 doing?
Up 3.
Up 3. So like I said, last chapter wasn't near as important as this next one's going to be, but it kind of sets the tone. By the way, what does this negative, don't worry about the 2, but what does the negative mean? That negative means what's happening? Anyone have any idea what that negative means? Yeah, it's reflected over the x-axis, reflected over x-axis. But in plain English, what does that mean? It means all of a sudden it is opening down. So if that a value is negative, it's reflected over the x-axis or it opens down. And what does this 2 mean? So this 2 means it's being what? Stretched or shrunk? Which one do you think?
Stretch.
Stretched. Now that's everything that we learned about absolute values and graphing them last chapter. So really my vertex then would occur at the point positive 1, positive 3. So it's been moved right 1, up 3, it's been reflected over the x-axis, and it's been stretched. Make sure you know what the vertex is, and this is not so bad, okay? Now, we are gonna do the exact same thing. By the way, I know a lot of people kind of panic here. Transformation of quadratics. Does anybody have any idea what a quadratic is? Especially in math. What's a quadratic?
Four-sided shape.
So he said a 4-sided shape. Why'd you say that?
Quad is 4.
Because quad typically means 4, right? Your quadricep in your legs has 4 parts of that muscle. Quad typically means 4. Now, that's kind of what I was expecting, but in math, it means something a little bit different. Remember, last year in geometry, you guys were studying quadrilaterals, not quadratics. And let me show you the difference. The reason it's called a quadratic is because if we had a 4-sided shape, and this was x, and this was x, how would I find the area?
Multiply x by x.
Yeah, exactly. So x times x is really just x squared. That's why it's called a quadratic. Now, I'm going to put this in plain English, but a quadratic equation or expression is any expression where your highest exponent's a 2. So something like this is a quadratic expression. Something like this is a quadratic expression. All right, what makes it a quadratic expression? The highest exponent that you see is a 2. Now, that's kind of pre-teaching, and we've got 3 days to run through this. But here's what you need to know. Again, I don't care if you, I want to get rid of that. I don't care if you write this down or take a picture, but you have to know this. A quadratic equation is an equation where your biggest exponent is a 2, which we would say something squared, like x squared. Quadratic equations make a U-shaped graph called a parabola. And we're going to study these parabolas for 2 weeks, but they're either going to look like this or they're going to look like this. Does
Mr.
anyone
Riley.
have an idea who Goated is?
Mr. Riley.
Yeah.
Mary, she texted me. She said her mic isn't working and she can't see your screen.
She can't see my screen. Oh boy.
She said all she sees is your face.
Do you guys see my screen?
I mean, I can see it. I don't know what's wrong with it. Yeah.
Yeah, Mary, you probably don't want to just sit and look at my face all day. That's bad. And that's a bad 50 minutes. I'm sorry. Tell her to, Mary, if you can hear me, log out and try and come back on, okay? They said that there were some issues with Zoom. All right. Yeah, fair enough. All right, so it is a U-shaped graph called a parabola. It has to either open up or open down. I'm going to go ahead and skip past this page. Now, here's everything you need to know, and I would make sure that you have this either written somewhere. Remember, we've got a quiz next Friday. You can use your notes on your quiz. There's nothing wrong with using your notes on your quiz. We want you guys to have the information. We want you to be able to find it. We also want you to know it. So we're starting in vertex form because that directly looks like your absolute value form when we're graphing that. Does anybody have any idea who Goated is?
You said who?
Goated, G-O-A-T-E-D. By the way, I'll send them a message here, I think. By the way, I can't let you guys in if you don't use your real name for obvious reasons. All right. So take a minute, write this down, or make sure you know it, or take a picture, whatever it is. We're going to discuss this here in about 30 seconds. Now, I also have some really good news. While I opened up your homework today, it is not due until Thursday. In fact, you won't even know how to do most of it until after class tomorrow. But instead of having a bunch of small, like 8 to 10 question assignments, we're going to have a bigger, like 20 to 25 question assignments that goes over the entire section. That way you guys will have a chance to ask more questions, do it as the next day in class without punishment, or attend a help session. So let's go ahead and do this. So vertex form looks like this: y equals whatever's in front of the parentheses. That's your a value. In your parentheses has to be squared. That's what makes it a quadratic. All right? How x is moving, whatever's happening here is going to move it left or right. And this is still going to move it up or down. So it works exactly the same as an absolute value. Your vertex is always, always, always going to be the opposite of what's happening to x. So if I have something like this, y equals x minus 2 squared, my vertex is really, and let's say plus 3, my vertex is the opposite of what's happening here. So it's positive 2, positive 3. If you are describing the transformation, it's moving it right 2 up 3. And that's why we started class like this. Any questions about H and K? All right. So the next thing is this. Now, notice I talked about the absolute value of A. I am not trying to throw you off. If A is negative, it's a reflection across the x-axis. So if A is negative, it still opens down. If it's positive, it has to open up. Hi, Caden. Was that you undergoated? Sorry. All right. So, and that's not LAL, that's supposed to be absolute values. So the absolute value of A, which means if I have a number like this, y equals 2, x minus 1 squared plus 3, if that A value is greater than 1, the absolute value of A is greater than 1, it's still being stretched, which means it's going to go up quicker. It's going to look something like this. If it's a fraction, like 1/2, it's going to be wider, or it's going to look something like this. Hey, that kind of looks like a person there. Anybody else see it? No? Okay. Sorry, being kind of funny. But remember, if A is negative, it has to open down. If it's positive, it opens up. Any questions at all? Yeah, okay. No big deal. So, today we are describing the transformation. And that's all we're doing for today is describing the transformation. And then we're going to also start talking about the vertex. So I want you guys to take a minute and see if you can do 1 and 2 first. Actually, try 1, 2, 3, and 4 first. You're just describing the transformation, doing nothing else. Wait for number 5. Wait for the end to do number 5. So I'm going to give you guys about a minute and a half to describe the transformation for 1 through 4. Take about 30 more seconds and we'll get going. All right. So what'd you guys get? Somebody help me out with number one. Describe the transformation of the parent function. So what'd you get for number one? Anyone?
Right 3 up 4.
Can I get somebody to verify that or correct it?
Yeah, that's what I got.
All right, good. And that's exactly right. So it's exactly right. So right 3 up 4, remember it's the opposite of what's happening to x and then up 4. So right 3 up 4. By the way, so my vertex, if I were graphing this, which we're going to do tomorrow, my vertex would be the point 3, 4. Very simple. Now let's do this one thing at a time. Number 2, what's that negative mean?
It reflects across the x-axis.
Perfect. Reflecting across x-axis. And let's put it in plain English. That really means it opens how?
Down.
Good. So if it's negative, it has to open down. Now you don't have to tell me that. Reflection across the x-axis is perfect. And then it's moved what? Left to right 1.
Left.
Perfect. Left 1 and then
Down 2.
perfect. And what's my vertex at? Where would I start graphing this? At the point? So if it's left 1 down 2, it would be -1, +2. So the opposite of what's going on here, that stays the same. Now, those were just to make sure that you guys had the right form. Number 3 throws a lot of people off. So do I think that this is going up 1, down 1, left 1, right 1? All I see is this. Compare what we see in number 3 to like this one and this one. What do you think that that one's doing? Is it happening to the x or outside the x?
It'd be the y, so it would be outside.
That's exactly right. So if you look, so if it's going to be with the h value or with the x, it has to be being squared. It has to be with the quadratic. So this is exactly the same, and I hope you guys are watching, as this, x minus 0 squared plus 1. Now, if I wrote it like this, almost everybody would tell me that my vertex is at 0, 1, but I'm not ever going to write it like this because we don't write plus or minus 0. So how has this been transformed then? Just up 1. Any questions? All right. So number 4, it's putting it all together. Before we get anything even remotely tricky, what is this 1/2? What's the 1/2 done to the quadratic?
Shrinks.
Perfect. So it is a shrink or shrunk by a factor of 1/2. Again, most of your assignment, it's going to say shrunk or stretched, and then, or it'll be a blank, and then it'll say by a factor of. So it's really going to be kind of drag and drop. Again, this homework assignment is not due until Thursday. And then it's moved what? By the way, is this opening up or opening down?
Up.
How do you know it's opening up?
Because there's no negative sign in front of the 1/2.
Perfect, Latavia. So yeah, A is positive, so it has to open up. So then it moves left to right 2.
Right.
Right 2 and
Down 3.
perfect. And what's my vertex at again? If I were graphing this, how would I graph it? Start by what, at what point?
-2, 3.
So she said -2, 3. Is that correct?
-3, sorry.
-2, -3. You're closer, it's half right. Remember, it's always the opposite of what's here. And I'm glad that you're volunteering because a lot of people would have missed that also. So it's the opposite of what's in here. So if I see a -2, it has to be positive. If I see a +2, it has to be negative. So it's +2, -3. Any questions? All right, the last one is a trick question. Why do you think it's a trick question? What makes this any different than this or this?
They're multiplying.
We have 2 times x. I have a coefficient for x here. If you ever have a coefficient for x in here, you have to go ahead and square both. So I'm squaring both the 2 and the x squared. So this is really saying y equals 4x squared. Now, we don't really talk about this, but you might see something like this. So most people would have said, oh, it's being stretched by a factor of 2. It has not been stretched by a factor of 2. What's it been stretched by?
Factor of 4?
Yes. So the only time you actually have to square anything is only if there's only a leading coefficient here for your x value in the parentheses. And what's my vertex, by the way, going to be? Is it moving left or right at all, or up or down at all?
No, it's not moving.
So then what do you think the vertex is going to be?
0.
Perfect. 0, 0. So if I haven't moved it left or right, there's not a plus or minus inside or outside, it's 0, 0. Now, we're not going to spend a lot of time about this today, but tomorrow I'm going to show you how we're going to start. So tomorrow we're going to start by graphing y equals x squared, and then we're going to graph those 5 that we just did. So I'm going to teach you a couple different ways to graph. Let's go ahead and kind of pre-teach this before we get into it tomorrow. So y equals x squared. Always, always, always start with your vertex. So what's your vertex on this one in the red, not number 1? What's your vertex for that? Did it move left or right or up or down at all? Anyone?
3, 4?
No, not this.
Negative-
We're just doing the one in the red. Yeah, don't worry about all this stuff down here. So if I'm just graphing y equals x squared. In fact, let me do this.
0, 0?
It's just 0, 0. Good. So let's just get our own. That's going to be tomorrow's notes. So if I've got y equals x squared, you always start by finding your vertex. So I'm not adding or subtracting anything at all inside or outside, so it's 0, 0. Now, next week, we're really going to focus on something like, or next week, on Thursday, we're going to focus on something called the axis of symmetry. But I'm going to introduce it now. So it makes a U-shaped figure called a parabola from wherever your vertex is. So let's say I have a point right here. Well, axis of symmetry would mean if I took one step over, I'd have to go the other direction and go here. All right? So that's kind of how it looks like. Now, the axis of symmetry is important because of this. Now, I'm going to teach you guys to do this by making a table first. But in the long run, I'm going to teach you to get away from making the table. I'm just using this to explain why it looks how it looks. Your vertex always, always, always goes in the middle. Now, this is going to look like a number line. So remember, my axis of symmetry is 0 or x equals 0. So I have to take an equidistant step up or down. So I'm going to switch colors here real quick, and I want you guys to follow. So hopefully you can start your homework tonight. Without this, you wouldn't be able to even start it tonight. So if I go up from 0, what's the next number bigger up than 0? Up from 0.
1.
1. And if I go down from 0, an equidistant step, it has to be -1. Now notice I said equidistant from the vertex, from 0. So what if I went up to something crazy like 3? If I went up to 3, where should I go down to on this one?
-3.
Good. So it has to be equidistant. Now, I don't really need to use 3 and -3. So I'm going to actually get rid of that. And I'm going to keep this looking like a number line here for right now. I just hope you guys follow. And I will teach this from scratch tomorrow. I'm just trying to tie it all together. Now, what the axis of symmetry means, if this is an equidistant step, then these two y values should be exactly the same. Well, what would you rather plug in, 1 or -1? It doesn't matter, there's no wrong answer. Let's plug in +1. So we're just going to plug it in. So if I plug in 1 right here, what is 1 squared? One squared is just 1. So right away, I know that -1 would also be 1. If you don't believe me, try it and plug it in. -1 squared. -1 times -1 is +1. Let's do the same with 2. Plug it in. What is 2 squared? 4. So again, if these are an equidistant step, then the values have to be the same. What is -2 squared? Also 4. And now you're plotting the points. So 1, 1, -1, 1. 1, 2, 1, 2, 3, 4, 2, 4, -2, 4. So that's why the axis of symmetry is important. Notice my y values are the same and they are an equidistant step from this axis of symmetry. Now, what if I would have plugged in 3 and -3 over here? 3 squared is 9, -3 is 9. So 1, 2, 3, up to 9. So then I can go same y value, 1, 2, 3. It's very easy to graph. That's it. Now, I'm not going to spend more than about 3 or 4 minutes doing one more example. And basically, I'm trying to give you enough to just start your homework tonight, and I'm really going to teach this tomorrow. So let me show you how easy this can be. So I hope you guys are following. Always, always, always start by analyzing and seeing what this should look like. First of all, is this going to open up or is it going to open down?
Open up.
How do you know it opens up? You're correct. How do you know?
There's no negative sign before the parentheses.
Perfect. So I know that this opens up. So I know it's going to look something like this, right? And what's my vertex at? Where do I start? Is it -2, -3, +2, -3, +2, +3, or -2, +3? What is my vertex going to be? I need some help here. I'm only hearing from about 4 different people.
Would it be -2, -3?
That's exactly right. Thank you, Cassidy. That's perfect. So it's the opposite of what's happening to x. That's why we have -2, -3. So when I graph that, -2, -1, 2, 3, And I know it opens up. That's my vertex. And when you see me shorthand it, I'll just write V at. So your vertex at -2, -3. So again, on Wednesday, I'm going to teach you to get away from the table, but you have to understand how to make the table first and how we can get away from it. So the vertex always goes in the middle. So -2, -3. I'm going to switch colors. What is my value directly bigger than -2?
-1.
Perfect. And if I went one bigger, I have to go one smaller. So I would be at -3. What's my value one bigger than -1?
0.
If I go up one again, then I have to go down one again. So I'm at -4. Again, the reason it has to be an equidistant step so that these values will be the same. So these values will be the same. So would I rather plug in -1 or -3? There's no wrong answer. Well, I'm going to plug in -1. I plug it in for x. What is -1 plus 2?
One.
And 1 squared is?
1.
And 1 minus 3 is -2. Well, I can go ahead and do that again. Here's my axis of symmetry, and I want you guys to see how the axis of symmetry makes this really easy. So -1, -2, axis of symmetry. So one step over to the right, one step to the left. There we go. Well, let's see. Would I rather plug in -4 or 0? I'll plug in 0. What is 0 plus 2? Come on, guys. I know we're tired. It's Monday. 0 plus 2 is what?
2.
And 2 squared is?
4.
4 minus 3 is?
1.
1. So there we go. Again, I'm at 0, 1. So if I took 2 steps over, I take 2 steps over, my y values are the same. Whenever you're graphing, you must have at least 5 points. There you go. There's your 5 points, and that's how you graph. It's not very difficult. There's a lot of places where you might make a small mistake. Again, that doesn't make it hard. That just means you have to pay attention to your details. Now, that should be enough for you to start your homework tonight. Tomorrow, we're really going to get into graphing, especially when your A value is not just 1. So there you go. Your assignment, again, I would take a look at it. The reason we're giving you guys 4 days to do this, you've got until Thursday night to turn it in so that you have a chance to ask questions and attend a help session either Wednesday after school, Thursday before school, or during class, okay? Tomorrow, we will completely talk about how to graph this. And then on Wednesday, we're going to get away from the table a little bit and keep talking about equidistant steps. Does anybody have any questions at all? All right, then I'll stop recording here.